let's take a look at finding the area of this region here. So the area under the graph of 9 minus x squared when x is between 1 and 3. Okay, so first things first, let's determine the width of the rectangles we're going to use. So the width is just going to be the total length of the interval, in this case 3 minus 1, it's a length of 2, divided by the number of rectangles, but remember we're going to take a limit of the number of rectangles as the number of rectangles approaches infinity, so we're just going to call that n for now, the number of rectangles, which gives us 2 over n is the width of each rectangle. So looking down here, if we start at 1, then the next x value we need to choose is 1 plus 2 over n. That will make that first rectangle have a width of 2 over n. The next rectangle will be 1 plus 4 over n. I'm sorry that writing is so small. And then 1 plus 6 over n. And I don't mean to indicate or to confuse you by saying that these are the actual widths. That's much bigger than the actual width would be if we use a lot of rectangles. It's I was just marking values. But anyways, let's examine that a little bit more. What is 1 plus 2 over n? Well, this is equal to n over n. That's just 1 plus 2 over n, which is equal to n plus 2 over n. So now what we're going to do is we're going to find a pattern for the heights of this function. So our first x value we know is n plus 2 over n. So that means the first height is f of n plus 2 over n. Right? If this is the x value, f of that value gives us that first height. So this is the height of rectangle 1. So maybe I'll write it as h1. Then f of n plus 4 over n is going to be the height of rectangle 2. I didn't actually do that calculation, but it's pretty clear to see. N plus n, n over n plus 4 over n is n plus 4 over n. Okay, so f of n plus 6 over n is going to be the height of the next rectangle, rectangle 3. So now we have enough to try and conclude what is the height of the ith rectangle, right? And this is pretty much the hardest part of doing these sums, is just figuring out a formula that will give you the height of the ith rectangle. And it's not that hard, as you can see. What is it in this case? N plus 2i, right? Over n. Because if we wanted the height of the second rectangle, for instance, it's n plus 2 times I, which is 2, which is 4. That works. Third rectangle, n plus 2 times 3, which is 6. That works. Let's just go ahead and make sure that it works for the last rectangle. So the last rectangle is going to be the nth rectangle, right? If we have 1,000 rectangles, the 1,000th rectangle is the last one. So if we have n rectangles, the nth rectangle is the last one. So this becomes n plus 2n over n. This is the height of the nth rectangle, the last rectangle. And let's simplify that. Well, n plus 2n is 3n. So this is 3n over n. The n's cancel and we just get f of 3. Well, 3 is our last x value. So this formula jives with what we know, which is these are this is the pattern which gives us the height of any rectangle. Okay, so we've got that. So let me erase this down here, just to give myself more space. Okay, so now what's the next step here? Well, now we need to take the limit of the sum. Well, first of all, let's write out the sum. Let's write out the sum before we take the limit. So the sum as I goes from 1 to n of the heights of the rectangles, which we just figured out the pattern, n plus 2i over n. This would be an equal sign. Times the width, which is just 2 over n. And we know that we're going to take the limit as the number of rectangles approaches infinity. So why don't we write that out right now? And now we can start evaluating this sum. So let's see here. Let me rewrite this limit. some teachers will take off if you don't, and I agree with that sentiment. It's different without the limit. So the first thing we got to do is plug in the insides of this into our actual function. So let's do that. So n plus, this is going to be 9 minus n plus 2i over n all squared, because that went in for x, times by, that whole thing times by 2 over n. So this was just the height times the width still. Okay? So we'll rewrite this limit. What can we simplify? Well, let's break this up into two sums. So now we have to bracket off the limit so that we know we're taking the limit of the whole thing. So I'm going to do a couple algebraic steps here at once. I'm going to multiply this 2n inside, so that will become 18 over n. The 9 becomes 18 over n. And then I'm going to subtract the sum. So I'm breaking this into two sums now of 2 over n, because I multiplied that inside, times by this n plus 2i over n squared. Okay, so it's the limit of this whole thing. And now I'm actually gonna leave this at the top of the screen, but I'm gonna move down here because I want to give myself a little more room. Okay, so the limit as n approaches infinity of, well, what's this first sum evaluate to? Remember, we talked about a constant. The sum of a constant is just this limiting value n at the top there, n times the constant. So 18 over n times n is just 18. So this is the limit as n goes to infinity of 18 minus then this sum here. So let's start evaluating this other sum. That's the, algebraically, this is the harder part. So 2 over n times by, this becomes n squared plus 4ni plus 4i squared all over n squared. Okay. And this is the limit of a difference. We know that we could break this up into two limits. And the first limit, the limit as n approaches infinity of 18, well, that's just 18. So let's just write that as 18 minus now this limit here of this sum. The limit as n approaches infinity of this sum. I goes from 1 to n. Well, why don't I actually 2 over n times this whole thing. Why don't I start breaking things up a little bit here? So let me rewrite this. So this is the limit as n goes to infinity of, and now I'm going to break things up a little bit. I'm going to write 2 over n cubed, so that's this 2 over n and this n squared down here, if you just factor those out, times by the limit as I goes, the sum from, times by the sum, so I goes from 1 to n of n squared plus 4ni plus 4i squared. And now I'm running out of time a little bit. So the way that we would end up solving this is now break this up into three sums. So actually, let me write that last step, and then I'll let you evaluate from there. So the last thing is 18 minus the limit as n goes to infinity of, and now we have 2 over n cubed times by the sum as I goes from 1 to n of n squared plus the sum as I goes from 1 to n of 4n times I plus the sum as I goes from 1 to n of 4i squared. Okay, so I've done the hard work for you. Now all you have to do is evaluate these three sums, and you have all the tools you need to be able to evaluate those. Okay, good luck, and I'll see you in the next video.